We hear constantly about ransomware, right? Businesses getting hit, computers locked, data held for ransom. It's everywhere in the digital space.
It really is.
But what if it's not just about your files? What if the target is like the actual machinery,
Yeah.
the physical stuff, pipes, power lines, assembly lines, the things running the real world?
And that's exactly where we're focusing today. We're diving into this growing threat of ransomware hitting what's called operational technology, or OT.
OT. Okay.
Yeah, think about the control systems for, say, manufacturing plants or critical infrastructure, water, energy, transport networks,
The really essential
the
stuff.
really essential stuff. And this deep dive, it's grounded entirely in the source material you gave us.
Mhm.
Our aim here is to pull out the key insights on why these OT systems are so uniquely vulnerable and why the consequences are often so much more severe when they do get hit.
Right. So our mission today,
Right.
let's figure out what makes OT such a tempting target, how these attackers are actually getting in, and really understand the real world impact, the kind that goes, well, way beyond just losing data.
Let's do it.
Okay, so starting right at the beginning, why OT? Why are attackers increasingly looking at these systems, not just the usual IT targets? What makes them so, I guess, attractive or vulnerable?
Well, what's really interesting here, and it's something the sources hit on hard, is that a lot of these OT systems, they were designed decades ago.
Right.
And back then, cybersecurity wasn't just a low priority. Sometimes it just wasn't even on the radar compared to making sure things were reliable and safe.
Built for a totally different time before everything was connected.
Exactly. And the first huge vulnerability factor the material points to is just that: aging and crucially unpatched infrastructure.
Okay.
You've got legacy systems, sometimes running hardware and software that's literally decades old. The absolute top priority has always been stability. Just keep that critical process running smoothly,
Don't touch it if it works.
pretty much. And that means they're incredibly difficult, sometimes physically impossible, to patch against known security holes that attackers have known about for years.
Wow. So systems running vital services have known weaknesses, things attackers could, walk right through, and you can't just click update. That sounds, yeah, like a massive problem the sources are highlighting.
It's a huge one. And here's where it gets even more concerning, frankly. This thing called IT-OT convergence.
Heard that term.
Right. So for years, many OT networks were totally separate, kind of air-gapped from the main business network. But now, with digital transformation, the industrial Internet of Things, IoT.
Connecting industrial machines to the internet.
Exactly. It means these previously isolated OT networks are increasingly linked up to the corporate IT network.
And if you connect them, suddenly the less secure, maybe more easily breached, IT network becomes a doorway into the OT side.
That's precisely the risk. An attacker gets into the IT side, which is, let's face it, a more common target, and they can potentially use that connection to sort of pivot, move laterally right into those critical industrial controls.
Okay, that makes sense.
And compounding that, the sources show there's often pretty weak network segmentation within the OT environment itself, or just not enough separation between the IT and OT zones.
Meaning?
Meaning if ransomware lands on one machine in the OT network, it might just spread like wildfire because those internal walls, those firewalls or segmentation points, they just aren't strong enough or aren't there.
So the very connectivity that brings benefits is also opening up these really dangerous new avenues for attack that the sources are flagging.
Absolutely. And then you layer on the kind of stark reality of operational priorities. In OT, the absolute non-negotiable needs are uptime and safety.
Keep the lights on, keep the factory running.
Exactly. You have to keep the power flowing, the production line moving,
Yeah.
the chemical process stable, whatever it is. And this puts organizations under just immense pressure to get things back online immediately if there's an attack.
Which I'm guessing the sources point out is a massive incentive for the attackers.
Oh, absolutely. That intense pressure means the victims are probably far more likely to pay a ransom and pay it quickly, just to minimize that downtime and, crucially, the safety risks. Attackers understand this. They know the stakes are incredibly high in OT, and that makes it a very attractive, potentially high-yield target compared to, say, just encrypting some data that a company might restore from backups anyway.
It's a pretty cold calculation on their part, isn't it?
It is. And one more thing the sources bring up, traditional OT environments often just lack the kind of sophisticated real-time threat detection and monitoring you see in IT.
So it's harder to even spot an attack happening.
Much harder. Harder to see what's going on in the network, spot malicious activity early, and then, contain it before it does widespread damage. Plus, you still have these almost surprising vulnerabilities from human factors and maintenance,
Like what?
like routine stuff. Engineers using USB drives to do updates or configure systems, maybe without really strict scanning protocols, that can accidentally bring malware right into an otherwise isolated network.
That's wild. You've got this cutting-edge IoT convergence creating new digital paths. But something as basic as a USB stick can still be a major weak point. It really shows the mix of threats, the source's detail.
It's exactly that mix of old vulnerabilities and new attack surfaces that makes OT security so complex.
Okay, so that paints a really clear picture from the sources about why these systems are so exposed. Their history, the connectivity, the operational pressures. But how are attackers actually getting the ransomware onto these systems? What are the common ways in, according to the material?
Yeah, the methods aren't always revolutionary, but their effectiveness in reaching these really sensitive OT zones is what the sources are stressing. Still, number one, phishing and social engineering.
The classics.
Always. Targeting employees, tricking them into clicking a bad link or opening an infected email attachment, often on their regular work computer, which might be connected, even indirectly, to the OT network.
So the human element is still often the first domino to fall, even in these super technical environments.
It very often is. Another big one highlighted is exploiting remote access tools. Many OT systems need remote access for monitoring or for maintenance by vendors or internal teams. If those connections use weak passwords or run on outdated software or aren't properly secured, well, they offer a direct highway into the network for attackers.
Exploiting the very connection that's needed for support. Makes sense.
Exactly. The sources also really emphasize supply chain and third-party compromise.
How does that work?
Basically, breaching a less secure supplier or a contractor or maybe a partner company who has legitimate access to the target's OT network for their work. Once the attacker is inside the third party, they can use that trusted connection to move laterally into the main target's environment.
So you don't even attack the main target directly first, you find a weaker link in their chain of trust.
Precisely. A very common tactic. And, like we just touched on, removable media is still a surprisingly persistent vector.
The USB sticks again?
Yep. USB drives, maybe laptops used for maintenance. They're used for software updates, pulling data logs, or configuring systems, especially older or isolated ones. If they aren't rigorously scanned and managed, they're an easy way to carry malware right past the perimeter defenses and plug it directly into the OT network.
It feels almost archaic, but the sources are clear it's a real and current danger in these specific contexts where maybe manual updates are still the norm.
It absolutely is.
Yeah.
A significant risk factor that the research definitely brings to light.
Okay, vulnerabilities, check. Entry methods, check, based on the sources. But the huge difference here, the thing that really changes the game, is the consequences. This isn't just about losing files or paying money. What actually happens, according to the sources, when OT systems get hit by ransomware? Why is it potentially so much worse?
This is really where the nature of OT just fundamentally differs from IT. The sources make it crystal clear. The primary consequence isn't just, having your files encrypted. It's operational disruption on a physical level.
Actual stuff stops working.
Actual stuff stops working. Attackers can halt physical processes. They can shut down production lines, stop the flow of utilities like water or electricity, freeze up transportation systems.
It literally stops parts of the physical world from functioning.
That's it. The impact jumps right out of the digital realm and into our physical reality. And the sources really underscore this. Unlike most IT attacks, OT ransomware can potentially cause direct damage to machinery. And, critically, it can endanger human safety.
How?
By messing with safety controls or changing critical process parameters or disabling emergency shutdown systems, things designed to keep people safe.
Wow. Okay, that's a completely different level of risk. It's not just financial or data loss, it's potentially life and limb. The sources seem to be really hammering that point home.
They absolutely are. And then there's the recovery. Getting these systems back online after an attack, the sources note, it's typically far more complex, way more expensive, and much more time-consuming than recovering IT systems.
Why is that?
Well, it often requires manual work, sending specialized engineers out to the physical site, maybe even replacing damaged physical hardware components. It's hands-on work that can take days or even weeks, not just, restoring from a backup in a few hours.
So putting a complex factory or power plant back together is just a whole different ballgame than restoring a server farm.
Completely different beast. And the final major consequence the sources detail is the broader risk to public safety and the economy. Attacks on critical infrastructure, think power grids, water treatment plants, major manufacturing facilities, pipelines like Colonial Pipeline.
Yeah, everyone remembers that one.
Those kinds of attacks can have massive ripple effects, impacting huge numbers of people and potentially causing significant economic damage.
That makes total sense. You disrupt one critical piece, and the effects cascade outwards. The sources clearly show that with examples like Colonial. So, taking all this together, the unique vulnerabilities, the ways in, these severe physical consequences, how did the sources really draw the line between OT ransomware and the sort of standard IT ransomware we usually hear about? Can we lay out a direct comparison based on the material?
Oh, definitely. The sources give us a pretty stark contrast across several key areas.
Hmm.
First, legacy systems. OT, as we said, has high vulnerability because it's old and hard to patch. IT systems, generally easier to update, so let's call it moderate vulnerability there.
Okay, so the age and inflexibility of the actual technology in OT is a huge dividing line, according to the sources.
It really is. Then, network segmentation. The sources point out it's often weak or maybe even non-existent within O-key networks, which lets malware spread easily. IT networks. Usually they have stronger internal segmentation built in.
Gotcha.
Operational priorities are completely different too. OT, as we discussed, overwhelmingly prioritizes keeping the physical process running uptime and safety first, often delaying security patches. IT tends to balance data integrity and confidentiality more heavily alongside uptime.
So security often has to take a backseat just to keep the main function going in OT based on what the sources indicate.
That's a really key finding, yeah. Monitoring and detection. Also a big difference. Capabilities are typically pretty limited and less mature in OT compared to the more advanced security monitoring common in IT.
Harder to see the bad guys coming.
Exactly. And maintenance practices, OT, often relies more on manual updates, bringing in that higher risk from things like USB drives. IT maintenance is generally more automated, more controlled.
And the bottom line, the impact
Okay.
couldn't be more different, as we've discussed.
Precisely. The sources hammer this home. Impact in OT means physical disruption, potentially serious safety risks, huge recovery costs, and potential effects on public safety and the economy. In IT, the impact is serious. Don't get me wrong, data loss, system downtime, significant financial loss, but it's usually contained within the digital or financial realm without that direct physical danger component.
And the sources mentioned some real-world examples to make this concrete, right? You mentioned Colonial Pipeline.
They do. The Colonial Pipeline incident is a perfect case study, actually. Even though the ransomware initially hit their IT network, not the OT systems directly.
You're right, I remember that detail.
It forced them to shut down the critical OT pipeline operations anyway, purely because of the risk of the ransomware spreading across that IT-OT connection.
Yeah.
It shows how even an IT breach in a connected environment can cause the exact same physical disruption. And then you have specific ransomware groups, the source's name, like Black Basta, and even malware like Indestroyer 2, which seemed purpose-built to target OT systems directly, designed specifically to cause production shutdowns or mess with utility operations.
So pulling this all together from our deep dive into the source material you provided, it seems crystal clear that these operational technology environments, they face a unique set of vulnerabilities. It stems from their aging infrastructure, this increasing connection to IT, often having weaker security layers, and that intense operational pressure to just keep things running no matter what.
Absolutely. And I think the critical takeaway here, the so what from the sources, is that understanding these specific vulnerabilities and grasping the distinct, often physical impact of OT ransomware is just crucial. It really highlights threats that go way beyond typical cybercrime. These are threats that can potentially affect our personal safety, our essential services, and the economy in ways that directly impact the physical world around us, not just our data.
It really makes you think. Consider the critical systems that we all rely on every single day. You know, the power grid keeping our lights on, the water treatment plants providing clean water, the factories making essential goods. How exposed are they, really, given everything we've just unpacked from these sources? And what does this accelerating IT-OT convergence truly mean for our collective safety and security in the years to come? Definitely some food for thought there.